Good afternoon, everyone, and welcome to this session in the Shape Your Future series, where we are exploring the STEM career journeys of Australia's rising stars. Today, we'll be hearing from Dr. Rachel Climie and Professor Levon Khachigian. I'm Dr. Sophie Calabretto, and I'm an applied mathematician and fluid mechanist whose favorite fluid is blood. So I'm very excited about this session on vascular science today. As we gather from around Australia, I'd first like to acknowledge the traditional custodians of the lands from which we meet. I'm joining you today from the land of the Gadigal people of the Eora Nation. I pay my respects to elders past, present, and emerging, and to any Aboriginal and Torres Strait Islander people who join us online today. As we share and discuss our own knowledge and practices, we recognise the deep knowledge forever embedded in custodianship of country. Now, before we get into the session, you will have seen that this session is being recorded. So this and all talks in this series will be available on the Stellar YouTube channel for you to revisit anytime you like. There is also a Q&A button at the bottom of the screen. So if you have any questions, drop them in there and we'll get to them either during the talk or in the discussion at the end. You'll see there's also a chat function, but any question should be in the Q&A section. So make sure you stick them in the Q&A because we don't want to miss any of your great questions. Finally, you'll be sent a feedback form after this session to the email you registered with. So please let us know what went well and maybe what you'd like to see in our series next year. So without further ado, firstly, I'd like to introduce Dr. Rachel Climie. Welcome, Rachel.
Well, thank you very much. So I'm just going to share my screen now and hope that it works. Okay. Can you see that okay?
I'll just jump in and say, yes, we can, Rachel.
Yep, perfect. Okay, excellent. Thank you very much. Okay, hi, everybody. So I'm really excited to talk to you today about my life as an exercise scientist. So what is an exercise scientist? Well, as an exercise scientist, I focus on the human body. I explore how it works and moves, what happens to the body during exercise, how exercise can improve the quality of life for people living with disease such as diabetes or cancer, and how we can get more people to be more physically active. And exercise scientists can work with elite athletes such as Olympians to help them to improve their sporting performance, or they can work with people from the public, helping them to improve their health through exercise or recover from injury and illness through physical activity. And I'm extremely passionate about physical activity and how beneficial it is for our entire body. So that's why I choose to work with people from the public. So in particular, I work on how exercise can prevent heart disease. And this is because the heart and blood vessels are very important for how our body works and how it functions healthily. And importantly, more people die from heart disease than any other disease worldwide. And in fact, in Australia, one person dies every 12 minutes from heart disease. So specifically, my research focuses on the blood vessels, or what we call blood vessel aging. Did you know that if you actually took all your blood vessels and you laid them out and from end to end and measured how long they would be, it would add up to 100,000 kilometres. So this is approximately 6 laps around Australia. So it's really important that we keep them as healthy and functioning really well. And your blood vessels are like your body's own river system that really feed the nutrients to the rest of your body. And we can often see damage in the blood vessels before someone shows any signs of heart disease. So this is a way that we can identify people who may be at risk of heart disease. But if we don't keep our blood vessels healthy and we engage in unhealthy behaviours such as eating junk food, physical inactivity or smoking, then our blood vessels may start to age faster than we age. And even though you may look and feel healthy from the outside, your blood vessels may actually be quite unhealthy. And you won't know about this until something very unfortunate happens, like a heart attack or a stroke. So here you can see a blood vessel or an artery, and what happens over time if we don't look after them. So eventually the artery will become blocked and no blood will be able to travel through it and get to the brain or the heart, for example. And this is what happens when we have a stroke or a heart attack. And importantly, this process of what we call blood vessel aging starts early on in life. So it's really important that we stay healthy all the way across our lives. So here you can see the blue line shows the normal progress of our blood vessel aging as we age. But if we engage in those unhealthy behaviours such as eating a lot of junk food, inactivity or smoking, then our blood vessels will actually begin to age a lot faster. And that's shown in the red line. So for our research studies or experiments, what we do is we have volunteers come into our research lab and we can measure how well their heart and blood vessels are functioning. In this picture here, you can see a woman who's come in for the study, and we're doing an exercise stress test. So this is a max exercise test. She's pushing herself as hard as she possibly can, and we can see how well her heart and her blood vessels respond to that activity. In this picture, I'm measuring the blood vessel function of one of the study participants, which is shown on the computer screen there. And in these ones, we can look at how the heart and blood vessels function in the MRI machine, and we can actually add an exercise bike to the end of the bed there and get the participants or the study volunteers exercising while they're in the MRI machine to see how well their heart responds to the stress that is exercise. So when did I know that I wanted to be an exercise scientist? Well, I really loved playing sport and being active as I was growing up. And I was really interested in how the body works and the physiology, so how all the organs talk to each other. And I was also very interested in the benefits of exercise. So this kind of led me towards wanting to become an exercise scientist. So in particular, we know that exercise is very, very beneficial for pretty much every one of our systems in our bodies. If we engage in regular activity, it's beneficial for our brain health, our heart health, to prevent things like cancer or diabetes for developing. It's beneficial for our bone and muscle strength. And it's really important and helps us to have a good night's sleep. And as well as that, I think probably one of the most important things is it helps us to manage our anxiety or our stress levels. So engaging in regular activity can actually make us feel a lot happier as well. And it is free, and pretty much everyone can do it, do at least some form of physical activity or exercise. So this is why I try to encourage people to be as physically active as possible, as long as they can be, so that they can live a really healthy life. And we have a saying in this area of science that if exercise could be put in a pill, then everybody would be taking it because it's just so beneficial for us. So how did I become an exercise scientist? Well, at school, I liked science and maths subjects. And so I did these through later high school and in year 11 and 12. But when I finished school, there was no degree available that I was really interested in. So I actually enrolled in a business degree, which really, I guess, came closer to my interests at the time, because there was no degree related to exercise science. I then took a year off after I finished year 12, and I went overseas and took a gap year and travelled and worked overseas. And this was a really, really great opportunity for me because it allowed me to grow and to understand myself a little bit more and understand what I really wanted to do and what I really wanted to study. And by the time I returned back to Tasmania, where I'm from, there was a new course offered by the university, and that was the course on exercise science, which really fit all of my interests very closely. During my degree, I really loved learning about the cardiovascular system, or the heart and the blood vessels, because, as I mentioned earlier, it is the heart and the blood vessels are really central to how well the rest of our body functions. After I finished my degree, I then did an honours year, which is a year of research. So you get a little taster of what it's like to be a researcher. And I quite enjoyed that. And so I went on to do my PhD as well. In terms of what I was like at the STEM subjects at school, as I mentioned, I really enjoyed science and maths. I really liked the problem solving. I really enjoyed sports science as well. And as well as the exercise, being quite interested in how beneficial exercise is for us, I was also really interested in how the food that we eat gives us energy as well. So this all together sort of directed me towards this path towards exercise science. However, I did fail physics at school. Wasn't one of my best subjects, but that was no big deal really, because when I got to university, I could get the help that I needed to understand those concepts that I was having difficulty understanding in the physics subjects. A really great thing about being a scientist or a researcher is that we get to spend our days investigating and understanding topics that are of interest to us. So this is an example here of one particular topic that a colleague and I investigated a few years ago. We were quite interested in how our blood vessels function under in high altitude conditions. So with a group of friends, we decided to take some blood pressure monitoring devices with us when we trekked up to Mount Everest Base Camp, and we measured how well our blood vessels respond to high altitude. And this was a really great opportunity and really novel thing to do, which was very exciting to be part of. As a scientist, I've also been able to travel overseas and work with colleagues from overseas. And in fact, after I finished my PhD studies, I moved over to Paris and worked in Paris for 2 years with some colleagues over there. And I still continue to work with a lot of people from all over Europe, which is a really great thing to do in science. It is a very collaborative way of working. So in terms of any advice that I would give to my younger self, I think first of all, it's important that you understand yourself and what you are interested in and what you're not interested in, and what sort of contribution you want to make to the world with the work that you're doing. And it's all right to not know that now. I certainly didn't know when I was in high school, and taking time off to go overseas and to challenge myself overseas was a really good way to understand all of this about myself. Talk to people and ask lots of questions, because there are so many different areas of science available now, and careers in general available. And if you don't talk to people and ask those questions, then you'll never know. And yeah, exploring different opportunities, different options, I think is something that's really valuable to help you make up your mind about what you're interested in and what you want to go into. So finally, I have a little request from all of you guys listening here today. I need some help from some young scientists. We're trying to put together some material for high school students about the heart and blood vessels, and we need some students to advise us on how we should be doing this. So if you're interested in being involved, if your class is interested in being involved, then I've put my email address there for you if you want to get some more information and if you want to help us with that. We're also setting up a pen pal program, so students who will be involved in informing that material will be linked up with a scientist who works in heart disease from all around the world, and you'll be able to talk with them and meet with them and discuss what they do as a scientist. And if, you know, post the pandemic, if you're traveling overseas, then you'll be able to go and visit those scientists as well in their lab and to see what they do in their day-to-day lives. So finally, in terms of the key takeaway messages that I want to leave you with today, I'd say the first thing is to find out what you love doing and do that. And secondly, make sure you keep active your entire life. So thank you very much.
Well, thank you so much, Rachel. I actually had absolutely no idea there were so many blood vessels in the human body. 100,000 kilometers is insane to me. So I can really understand why it's so important to keep those really, really healthy. So I want to thank you so much for that. What we might do is now we might go to Professor Khachigian, and then at the end we'll open everything up and we can have like a nice little Q&A kind of panel chat. So I guess I'd like to introduce Professor Levon Khachigian. Thanks very much for joining us, and take it away.
Thanks very much, Sophie. It's a great pleasure to actually be here and to follow such a stellar presentation from Rachel Climie. I am a molecular biologist who's spent his life understanding or trying to understand mechanisms of disease. And so in terms of what my current position is, I am a professor in medicine at the University of New South Wales. And being a molecular biologist, I am interested in how molecules work, talk to each other, interact with each other, get modified, and how those modifications lead to changes in behavior of cells, and in turn, how those cells influence organs and how those organs function, cross-communicate, and respond to disease stimuli. I'm not only just a basic biologist, I'm also a translational researcher. And I've come to the realization, in fact, probably 20 years ago, I came to the realization that all of this knowledge that medical researchers are generating that end up getting published in very, very good journals and in textbooks shouldn't be allowed to essentially gather dust. That what we need to do is to translate that basic knowledge into impactful, measurable deliverables, so that doctors who work in clinics, who see patients with day-to-day problems, can have new tools so that they can tackle problems which are globally relevant, as in cancer, cardiovascular disease, problems such as, or related problems such as rheumatoid arthritis, or blindness caused by retinal disease. All of these diseases have unmet need, but not all diseases need to be globally significant. There are also diseases which are very rare, and they're as important as globally important or relevant diseases, because actually disease is a very individual thing, and one person's disease may not be shared by another person, but it's still very important to that person, and every person needs and has a right to health, good health. So what do we do, what do people like Rachel and I do in our everyday practice? Well, both of us are researchers, and Rachel interacts with people on a day-to-day basis. In my world, we interact with cells from animals and from humans in test tubes, and the molecules that are involved in that process. So our work is molecular biology mainly, with a strong focus on vascular pathobiology. So the patho is disease, and biology is the interaction and the movement, that dynamic ebb and flow of biology is what our interest is, particularly with regards to blood vessels, which, as Rachel said, connects all the organs together by virtue of the provision of oxygen, nutrients, and the taking away of toxic byproducts produced by the organs. So we conduct lab research, and in my current position, I manage researchers. I, like most researchers, conduct administrative duties. I supervise students and postdocs, that is, scientists who are comparatively senior after they finish their PhDs. I write grant applications. I look over grant applications by members of my team. And to encapsulate the work we do, we write manuscripts and papers so that other scientists learn of the important work we do. Now, that doesn't happen automatically, whereby you write a paper or a report and it gets published. It has to undergo rigorous peer review, and it's only published after other scientists consider it worthy of publication. Not all scientists do this, but I also like interacting with industry because it is a very important way of translating what's done at the bench, which can be comparatively sterile, to what happens beyond the window, that is, to the real world situation. When did I know I wanted to be a scientist? Well, I've always wanted to be a researcher, and I've always wanted to help people. So my own father was not so much, he wasn't a researcher, but he was, he's led a church. And I've seen a lot of that benevolence and that compassion that he's exercised. And I guess part of that by osmosis has filtered to me. So I am, like Rachel, very passionate about what I do, but there's a large element of compassion within a researcher, because at the end of the day, you can be passionate, but the compassion comes from wanting to actually help others, particularly in the field of health and medical research, where people suffer from disease, and that affects their lifestyles, their lifespan, which we call morbidity, and mortality, which is how long they live, and the suffering they have at the end. So you have to have, as I've had, a curious mind. You've got to be determined, and because this is a STEM-based talk, analytics is so important. Problem solving after troubleshooting, after asking questions. So I've had a long career in research. In fact, 2022 marks 40 years at the University of New South Wales. So I came to UNSW after graduating high school, which I understand is a few years away from you at the moment. I finished my high school in 1981, which was last century to most of you. I did a Bachelor of Science over 3 years. And then, like Rachel, I did an honours year. And I loved doing research so much. I happened to do it in biochemistry, and my undergraduate was in microbiology and biochemistry. I loved doing laboratory work so much, I was motivated to do a PhD, which I finished in '93. And then I was lucky enough to go to Harvard Medical School, where I spent 2 or 3 years working with brilliant minds that opened my own mind to so many possibilities of trying to find solutions to complex problems. So in the mid-90s, I then returned to UNSW, and I eventually got a Doctor of Science in the mid-noughties. So how was I with STEM subjects in high school, and how relevant were they in my career? Well, I love STEM subjects. I did, for my senior years, I did chemistry and physics and maths, not 3-unit or 4-unit maths. I did chemistry and physics and 2-unit maths, but I also love history. I love the arts. So I did significant amounts of music and English, history and economics. And so it really did provide a nice balanced flora, if you like, that helped me decide what I wanted to do. So I've just indicated that, and this is just in red here. So we had 4 or 5 science classes in high school. So I was actually in 8S4, which is this S stands for science. So 8S4, 9S4. So I was the second bottom or the bottom class. And then I realized that science was a way of making a difference. I could actually use what I was being taught by my teachers in a way to try and better understand how things work and how I can use that understanding to change people's outlooks and prospects in terms of their health. Now, to do that, STEM subjects help you think rationally and objectively. So rather than having a lot of fuzz in terms of what you hear day to day, STEM subjects help you rationalize that and make structures out of that information that comes into your ears. And that's the way that's when I think of STEM, I think of structure. I think of rational design and objectivism. So the special paths that I took weren't so much special. They were opportunities that I was presented with, and I seized them with both arms. So that's actually not me. But the barrow is something that helped provide my pocket money as a paper boy when I was going through early high school, so your stage. So this, I used to sell papers for 10 cents each, and I tried to read as much as I could those afternoon papers, the Daily Mirror, I think it was, the Sun. But then I towards the end of my first part of high school, I realized that perhaps I could work in a slightly more meaningful way, more focused way, and I became a chemist delivery boy. And the chemist would allow me to go behind the counter and actually count drugs or tablets being put into vials, and I'd deliver those. And before I closed the tops of those vials, I would ask the chemist to tell me about what these drugs could do or did do. And that then led to a two-week work experience at Sydney University's vet clinic and hospital, where it was really an eye-opening experience. I participated in surgeries, not so much doing them, but certainly observing what was going on with the small animals, and spending some time in the lab looking down microscopes, looking at specimens, trying to differentiate between normal tissue and diseased tissue, and so really that was the grounding for me to move on to some recognized awards and opportunities that helped propel and feed my desire to try and dissect mechanisms in disease and to exploit that knowledge in the generation of novel and new therapeutics. So in the early part of my career, I was able to get some fellowships and scholarships, and with a Fulbright scholarship and NHMRC support. NHMRC is like the National Health and Medical Research Council. That has which funds medical research in Australia of the order of about $800 million per year. So that also supports people, and so I was fortunate enough to get a range of fellowships: a research fellowship, principal research fellowship, senior principal research fellowship, something called an Australia fellowship, and that helped provide the salary support for me to write grants and employ people to do the research I did. And it's been a wonderful 4 decades. I wouldn't trade it for anything else. It's given me the opportunity to generate novel drugs, innovative approaches that go beyond the square in terms of how to deal with mechanisms or molecules, rather than throwing a hammer at something to hoping that it's going to land in the right place. You can use very fine microsurgical molecular techniques to try and identify and control problem, disease, or harmful molecules. Advice I'd give to my high school self would I think be to find a passion, and this is very similar to what Rachel very eloquently said. Find what you like doing, and also figure out what you don't like doing. And perhaps you could, on the left-hand side of a page, you could put a plus, and on the right-hand side, you could put a minus. Just put under the plus, just indicate all of the things you absolutely love doing, things that interest you, things that you don't get sick of. And on the right-hand side, do the opposite, and help use that approach to identify what your passion is. Once you work out what your passions are academically, then that should become your mission. Persevere at challenges that you have in front of you, and don't give up. Be relentless. And of course, you're going to fall. Of course, you're going to trip, because life doesn't have an instruction book. You're going to make mistakes. People will criticize you. But if you fall, just get up again. And remember that the sun will come out tomorrow. And that really is hope that we can latch our hearts around, because opportunities don't extinguish. You have to go out and find them. And to find them, you've really got to sort of build on and exploit the passion that should become your mission. So in STEM, there are, as you probably know, in terms of your background notes and instruction to this webinar, there are just a million things you can do, 1,000,001 things or more you can do with the education you're receiving now. So Rachel and I have spoken about vascular research or medical research, but with STEM, you could go into medicine, diagnostic pathology. You could instead of knowledge creation or diagnosis, you could exploit that financially by selling and marketing products that help other researchers or diagnostics people to conduct their art. But in order to do that, you've got to have an understanding, and that's where the basic science comes in. Biomedical and other types of engineering. My son's doing civil engineering, environmental science, sustainable material science, marine science, teaching, where you impart the knowledge you've generated or are absorbing, and you're passing that on to the next generation. Ecology, geology, astrophysics. Look at the diversity here. Optometry and vision science. Blood vessels aren't just tubes that run through certain organs. They connect every organ, the skin and the eye. And at the back of the eye, when we have abnormal blood vessels, we have problems of blurred vision, and we desperately need new drugs that can complement and improve prospects to those people who have globally important problems such as age-related macular degeneration and proliferative diabetic retinopathy. These are just some examples of where there is unmet need. But you might want to not do any of that and go into psychology, or use that problem-solving skills to try and figure out what is the best strategy for investment, making money, etc., or helping people deal with their social and other problems. So there's really no limit to what you can do with a career in STEM, and I applaud you for attending and exploring your passion in STEM. And really, it's an open door. It's an open door to endless possibility. But when you realize what you really want to do, going back to this image, just make sure that you exploit that and that your passion becomes a career mission. So with that, thank you again for listening, and I'll now stop this and hand you back to Sophie.
Amazing. Thank you so much, Levon. I think what I really loved was how you highlighted that every person has a right to good health, like the compassion that we see behind science. I think sometimes people forget, and you may be in a lab doing research looking at cells, or you could be working with people themselves. But really what it's about is using scientific tools to improve the lives and health outcomes of others, which I think is a great thing to highlight. So now we're up to the Q&A segment of this session. So please remember to throw all of your questions into the chat, not into the chat, exactly not the chat. Throw your questions into the Q&A function, and we will definitely ask them once they come in. So just to start off with, I've got a question for both of you, and maybe we'll go to Rachel first, just because you haven't been talking for a little while. And I want to know, what is the most interesting thing that you have worked on in your career, do you think?
Oh, that's a good question. I've worked on a lot of interesting things. I think probably the project that I showed at Mount Everest Base Camp, that was very interesting. It was quite novel and exciting to be able to do that and to be hiking along with our blood pressure machines attached to us. We actually saw some people coming down from Mount Everest, and they actually had an exercise bike with them, and they'd been partway up Mount Everest and had been doing some very intense experiments partway up the mountain, and we looked a little bit silly with our little 10-person study, but anyway, it was still a really neat opportunity to be involved in. I think probably the second project I would mention is one that I'm working on at the moment, which is in women with breast cancer. So we know that cancer treatment can actually be toxic to the heart and the blood vessels. And so we're doing a study at the moment where we're trying to see whether, if people exercise while they're taking that cancer treatment, whether that can mitigate the toxic effects on the heart and the blood vessels. So we get the women to exercise in the MRI machine. And this is quite a novel thing. One of the pictures that I showed during my presentation, I think us and only one other group in Belgium, in Europe, can actually have the facilities and the expertise to be able to measure the heart and blood vessels in response to exercise in the MRI. So that's quite a neat thing to be involved in, and actually to get in the MRI machine and try and exercise using a bike in there is very challenging, but it's fun to be involved in, that's for sure.
Yeah, I'm sure. Wow. Mm-hmm. And how about you, Levon?
Well, when I was in Boston, we were looking for a master regulator, using Rachel's analogy, someone who's actually sitting on the bike seat, driving the chain of the wheel. And so we'd like to call these master regulatory molecules that control other genes. And we discovered a very interesting protein whilst in Boston. And when I came back to Sydney, we set about targeting that protein. And we realized very quickly that with the tools we had in our toolbox, we just weren't at that level to be able to exploit that knowledge. And so we tapped the shoulder of a company, and we realized, and I think this is where the wisdom comes in, you have to realize what you can do and what you can't do. And that void, you need to, we want, our approach was to try and fill that void by bringing in that kind of expertise. And so this company had that kind of expertise. They taught us so much, and we were able to target that target that protein, that master regulator, and then we translated that that work from the bench all the way through to studies in rats and then pigs. And eventually we tested that in humans, first in man, first in class clinical trials. And so that, to me, is one of the real goals of what I do, to try and discover, exploit that basic understanding and have potential therapeutics that that could offer solutions in areas of unmet need. So that's the real interest for us. The other point to make is that from a supervisory point of view, it's just really interesting and very satisfying to see the penny drop. And perhaps Rachel could comment on this. When you've got students who understandably don't know everything or are comparatively naive when they come into the lab, when they understand concepts, you can actually hear the penny drop. And when experiments work, you can see the penny drop. And when they see what that experiment is telling them, by virtue of what a two-dimensional bar chart shows, and the penny drops, it's beyond words. It is just wonderfully satisfying to see that kind of graduation, if you like, in understanding and exploitation of that basic knowledge.
Yeah, great. Rachel, did you want to add any comments about the penny dropping?
I was just going to say, I guess, slightly different, but when we see an experiment work, so for example, the project that I mentioned in the patients with breast cancer, currently they're coming back now after their 4 months of treatment, and we're reassessing all of their heart and blood vessel function. And we can see that we haven't analysed all the data yet, but just from looking at the participants or the people who are coming back at the end of that 4 months, we can see that those people who were asked to do the exercise intervention compared to those ones who were just what we call control subjects, so they were not asked to exercise, you can see that those ones who are exercising actually have maintained their heart and blood vessel function, which is really, really exciting, because we know that what we're telling them to do is really helping them and really helping with their health and to maintain their health during this very challenging time for them during their cancer treatment.
Yeah, for sure. Great. So we've had a question that's come through the chat, and it is for Rachel. But after I ask this to you, Rachel, I want to flip this, and then I want your opinions as well, Levon. So the question is, why is it good to work with people instead of just doing lab work?
Oh, that's a good question. So I think for me, I'm quite a people person, and I really like working with people. And so for me, my interest was really to work with people in the clinic. And as I mentioned, working with patients with cancer, for example, and we're doing this work to really help them, it can directly translate into helping them with their health. Whereas I think the work in the lab that Levon and his team would be doing it gets more into the nitty-gritty, the detail of the what's happening at a smaller level, at the molecular level in the cells, which is very interesting. But for me, I like to be at the other end of the sort of translational pipeline, as we call it, where the work can directly be helping the individual as well. So that's why I chose that end. But Levon may be able to comment as to why he chose the other end.
Yeah, can you tell us what you think the benefit of doing lab work over people is? I'm really interested in this.
Well, first of all, it takes a village, doesn't it? This is what it shows, and so this is a STEM sourced village, really, because we are asking separate questions or different questions using the knowledge we've acquired from basic understanding of biochemistry, physiology, biology, chemistry, etc. I think dealing with molecules or test tubes or cells in culture does allow you to ask more detailed questions. It also allows you to test out interventions, and if experiments don't work, then you can go back and grow more cells or generate more molecules and approach the question from a different persuasion in a relatively short space of time. Whereas with human research, human subject research, that's not easy. Things work very slowly or comparatively slowly. And usually discovery research is done in larger scale with more detailed tools, and will provide a range of options, which then are whittled down to a handful of options, which people like Rachel then decide what is worth testing in a human situation. But you see, on the other end, where we are, we can test a whole bunch of things and see what does work. So we do a lot of the screening, for example, and the end product of that screening process, Rachel then can test in a controlled manner with people.
Now, I'll just add to that, sorry, Sophie, the joys of working with humans sometimes is that they can sometimes forget to turn up to do their experiment, or, you know, to the lab to participate in the study, or we might tell them that they can't have any coffee, or they can't eat anything before they come, because we need everyone to be in the same condition when they turn up, so that we're testing everyone under the same conditions. But sometimes people forget to do that, whereas when you're in the lab, I don't think the mice have access to coffee or anything like that. So
yes, exactly. So we control that. We control their diet, and we control how many rats or mice are in the cage, etc., etc. So that is exactly what that is a very good example of how one is controlled and the other one is a little less controlled.
Yes.
Yeah, great. Thank you for that. So I want to take, this is not really a 180, it might be a little bit of a 90, but you talked about sort of other areas of your life a little bit. And I just wanted to know, if you didn't become scientists, what would you have become? What were other jobs that were interesting to you when you were younger? Rachel, do you want to start?
Sure. So that's, again, a really great question. I think, as I mentioned, I was originally enrolled in a business degree, which is definitely not me at all. And I only enrolled because it was, you know, what was of most interest for me in Hobart. I think if I wasn't doing the science that I'm doing at the moment, I would really have loved to have done some marine science, because I'm quite interested in the ocean and, you know, and what's down there. So I think, and that partly at the moment toy with the idea of whether I can combine sort of health and marine science together. Maybe, I don't know, who knows. But I think maybe a teaching degree as well. I'm quite interested in teaching, and we can do that as part of our work as researchers as well. Yeah, so probably science, marine science, or teaching, I think would have been mine.
Yeah, great. What about you, Levon?
Well, I'm going to give you a different answer because, and it's not a STEM-based answer. It's I would have become a musician. I play violin, and I've had a lifelong passion in strings and the violin, and I play even now. So it's the two sides of Levon, the very rational, structure-based, STEM-based scientific medical researcher, and the open-minded violinist who plays anything from Bach to Nirvana.
Amazing. I love that you've highlighted that there really is a creative element to science that I think people forget. So I know that there are a lot of scientists who are actually amazing musicians and artists and things like that. It's really important to remember that those two parts of ourselves can actually complement each other really, really well. So just to everyone watching at home, make sure if you've got any questions, throw them in the Q&A, because we are in our last 10 minutes almost. So I know that you both gave some advice to your high school selves, but again, I'm going to mix stuff up a little bit. I want to know, is there anything that you would do differently now, looking back, maybe high school, early uni, or any stage of your life? Is there anything that you would change, or are you completely happy with the paths that you've taken? Maybe we'll start with, we'll go Rachel again.
Sure. So I think I certainly would have asked more questions and I would have explored more, because I don't think I knew fully what was available. Yeah, I don't think we had exposure to so much in STEM that was available, and there's certainly much more available these days as well. So I think, yeah, I certainly would have tried to explore a little bit more and even make contact with scientists or people in different areas that I had a little bit of interest in, and I would have tried to experience that a little bit for myself. So for anyone listening, I would highly recommend reaching out to people, reaching out to scientists or, you know, people in other careers that you're interested in, and going and hanging out with them in their lab or in their workplace for half a day or a few hours or something like that, just to have a look and see whether it is really something that you're interested in, because how are you meant to know if you don't experience it for yourself? And it's a big decision to make sometimes. So yeah, I'd highly recommend going in and having some experience doing that.
Yeah, I'd agree. I'd agree, Rachel. I think you know, when I was going through, we had a handbook. There was nothing. Well, when I was going through, sorry, Rachel. When I was going through, we had a handbook, a student handbook, in terms of what offerings there were at university. But of course, the internet's changed everything. And if I was to as I reflect, I think I would have asked. I would have done that list, that the plus and a minus list earlier in my life, to try and figure out what my passions are and what my mission is. I did it comparatively late, and it worked out okay. But I think that if it was done earlier, maybe that would have helped me funnel a lot of my energy into this career a bit earlier. So it's not really a regret. It's just a fine tuning of where I am at the moment.
Levon, I was just going to add that I actually did that list myself. I remember doing it when I was probably in the second year of my university degree. And because exercise science, you can either choose to go down working with elite sports people or working with people from the public with chronic disease, you know, cancer, diabetes, heart disease, and so on. And I was in a little bit of I don't know which way I want to go. And I wrote down my list, and I could see from the list in front of me that this is the direction that I wanted to go in. So yes, I think it's a really good point and definitely worthwhile doing.
Great, thank you. So we are sort of coming to the end of our time. So I know that you both offered advice in your presentations, but I was just wondering if there's a final message that you'd like to give to all our students watching at the moment.
Well, maybe I could start. I think in terms of advice, there is no textbook, as we talked about, and you may be making mistakes as you go from one chapter to another. But I think life is about exploring, being adventurous, interacting, and figuring out what works and what doesn't. You know, there are many scientists who are dissuaded by the current grant system, where funding is a major problem. As Rachel will attest to, we're looking at success rates of the order of 10 to 15%. That can be a dissuasion to some scientists, but having said that, it's really the passion to discover and the real desire that you want to make a difference to help people achieve their human right to health, that really should be the driver in a career in medical research, if that's what your persuasion is. So my advice is, don't be dissuaded. Trends come and go. If there are opportunities, seize them, or put them in the in basket, but make sure that they are attended to, because somebody else will take that opportunity. And most of all, you don't want to have regrets, and do ask questions. And if you fall down, get up scruff yourself off and keep on that journey.
Absolutely, I agree. I think my piece of advice would be to really find what you're passionate about and really do that. And I think that comes back to your point, Levon, where, you know, a career in science can be challenging, but if you deep down know why you're doing it and that you're truly passionate about it, then it helps you to get up every day and to go to work even when it's challenging, and to keep, you know, applying for more research grants and funding and that sort of thing. If you're truly passionate, then you'll keep going in that direction. And I think that maybe it can be challenging to figure out what you're passionate about. And sometimes that doesn't come from sitting in the classroom, and maybe engaging in activities outside of the classroom. So competitive sport, for example, or, you know, even traveling overseas by yourself can really open your eyes up to what you're interested in, and challenging yourself and growing and understanding all of that and finding what you're passionate about. So I would just encourage you to explore and to find your passion and then pursue that.
What amazing messages to end on. Thank you so much. I really want to thank you two for joining us today and sharing your journeys and all of this new information about vascular science. And thank you to everyone at home for tuning in. So don't forget that this series of talks was supported by the Victorian Challenge and Enrichment Series. And don't forget to fill out that feedback form when it hits your inbox very, very soon. So the Shape Your Future series will be continuing all this year. So you can tune in to hear from many more scientists, and all of this information will be available on the Stellar and ATSI website. So thank you again. Thank you, Levon. Thank you, Rachel. And thank you everyone who joined us at home today. I hope this was really beneficial for you. I had a great time and I learned a huge amount. Thank you.
Thanks, Sophie. Thank you.